This is the brief on tensor identity simplification. So, you know how vector algebra can get? Really messy? Well, the material here is all about a super powerful tool called the epsilon-delta relation. It's a game changer because it lets you turn the really specific Levi-Civita symbol, the one for cross products, into the much friendlier Kronecker delta, which basically just checks if two indices are the same. All right, let's dive into the takeaways. First up, the main task. The source is laser-focused on one specific problem: how to simplify the product of two Levi-Civita symbols when they share a couple of indices. And trust me, that's a situation that pops up all the time in vector analysis. Second, the method. So how do you actually do it? This is where that epsilon-delta relation really comes into play. It's the absolute key. You essentially use it as a substitution rule, swapping out that whole complicated product for a new identity that's built only with Kronecker deltas. You're trading a big headache for some really clean algebra. And finally, the result. What do we get out of all this? The entire thing just boils down to a single, beautifully simple expression. By breaking the identity down into manageable steps, we get a straightforward rule that turns these difficult tensor products into equations you can actually work with. This technique lets you resolve some of the toughest tensor products into a clear, simple expression using only the Kronecker delta.